Object-oriented programming is one of the core foundations in modern programming, not only in C++, but also in languages like C#, Java, and Python. If you understand these ideas, it becomes much easier to structure any kind of software, from small tools to full applications. In these lessons, we'll focus on 4 key pillars: creating your own types, controlling data, initializing the object properties, and using the famous this pointer. And later, when you move into Unreal, you will see that all of these principles are exactly what the engine is built on. Today, you will learn structs and classes, encapsulation with the members and methods, constructors and destructors, and the this pointer. This is the Game Creator Accelerator, and I am Tony Munoz. Like, subscribe, comment, and ring the bell so you don't miss new episodes of this series and many more related to Unreal and strategies for hacking the gaming industry. We are creating Mad Gameverse, a third-person shooter, and the entire code and the process are also available in this channel. And before we jump in, I want you to remember something important. Learning C++ and Unreal is a journey, and you don't need to master everything at once. All of these concepts will make sense step by step as you practice, build, and share your progress. If this feels new, that is perfect. It means you are growing. And if you ever feel stuck, slow down. Take one concept at a time, and then keep moving. That consistency is what separates future developers from people who quit too early. At the Game Creator Accelerator, we follow one simple idea: create something small and share that progress every week. This builds confidence, skills, and visibility. If you want a clearer path, structured guidance, and a mentorship to stay consistent while working after your daily job, visit Woolen.com or reach out to me directly. All links are in the description. Now let's get into the foundation of object-oriented programming. Object-oriented programming is about creating your own types that model something real. You can say a player, an enemy, an inventory item, weapon, projectiles. You group data plus behavior into one unit. This will help you, first, keep your code organized, second, reuse the logic, and third, scale your game without losing control. In C++, we have 2 basic concepts to use, which are structs and classes. In C++, there is almost no difference. Both allow variables and functions inside, both support constructors and destructors, don't worry, we're going to get that into a second, and both can have methods. The only real difference is the default visibility. Now let's present some code. Let's begin with the syntax for a struct. A struct, you write it like a struct, let's say player data, and then you define what will be in that struct. For example, integer and float speed. I forgot here, yeah, much better. The biggest difference is that this is public by default. Now, let's define a class. The syntax for a class is class, let's say player, and then we can define 2 variables, let's say health and the same float speed. These 2 will be private by default. I just checked that I have a mistake here. And this is the big real difference between these 2. Also, when we create classes in C++, we usually define the sections to be private, just to remember that this is a private. What is coming after this sentence, what comes is private. And also you can create a method, let's say a public method, and name it move. And later you can also add another section that will be private, and you just have to write private, and what comes after will be private as well. At this point, I have this warning because this move method hasn't been set. I just declared it. Now you can ask me, well, Tony, if they are the same, when should I use one or the other? Use a struct when you mainly want to store data with little or no logic. Think of it as a simple container or a record. A simple example is what we did here. Let's say we add another with mana. Another struct could be, let's say, resolution, where you define integer width and integer height. this example, we just group related values together. We're not trying to hide anything. We usually keep everything public and use it directly. Let's move this main function to explain it. I can declare here a player data and call it player data, and then access the data inside directly, like player data dot health will be 100, and player data, let's say speed, will be 600 F. And I can also recover this data. Let's say standard cout player data health and standard end of line. If I run this, you will see the hello world and the 100 corresponding to the player data dot health. You can also add functions and constructors to the struct. We're going to cover the constructors in a second, but the mindset is this is mostly data that is simple and safe to access. And what I mean about safe to access is that as programmer, you don't care if the gamer or other developer access this data, because you are sure that it won't break the logic of the rest of your code. The next question is when to use a class. Use a class when you want to model something like rules, behavior, and protection of its internal state. You usually hide the data and expose only the operations that make sense. Let's present an example, but first I'm going to copy this main to the bottom, and I will comment everything I did before. In fact, I'm going to remove this class. A beautiful example for a class could be the class bank account. I want the data inside this to be private. In particular, one variable called balance. And at the same time, I want to create methods. For example, the bank account, where I pass an integer called initial balance. Let's say balance initial balance, which is called the constructor, and we're going to cover that in a second. And I can add other methods like deposit with an integer amount, a boolean that will be withdraw, where you're going to pass how much money you want to withdraw, and let's say an integer get balance, which is a const. This is a great example of using classes because you don't want to give access directly to this variable name balance. You want to give people or other programmers the option of calling these functions. But what is going to happen inside these functions to change the balance is under your control. The consequence is that this lets you validate input, prevent invalid states, and keep control over how the object is used. So the mindset is, this is not just data. This is a small world with its own rules. A simple rule of thumb is that you can think of it like this. If it is just a bundle of values with no important invariants or rules, use a struct. If it has behavior, rules, or needs encapsulation, use a class. We're going to cover also the concept of encapsulation later, but it's related to what we did in this example. At the same time, keep in mind that both can have constructors, destructors, methods, and access modifiers, what we define as a public, private, and in the future also protected. We're going to the details of constructor and destructors in just a second. So the choice is less about what C++ allows and more about how you want other parts of your code to use this type. When you work with frameworks like Unreal, you will see both patterns in action. Simple structs to hold data and powerful classes to drive behavior. Let me remove this slide before getting to the next concept, which is encapsulation. Encapsulation means hiding the internal details and exposing only what is needed. It is one of the biggest tools to protect your code from accidental bugs or to protect it from other developers. Let's create a new class named weapon. And we have a private variable that is called ammo. And then we define some public methods, which are void shoot and void reload, where we pass an amount to reload. Encapsulation is about not allowing get access to this information. For this example, players cannot directly change the ammo. They must go through the methods that will reduce the amount of ammo or increase the amount. This creates predictable behavior. You decide what can or cannot happen. And at the same time, inside this method, you can create other conditions, other things that you want to happen at the moment that this ammo is updated. That is why we as programmers don't usually give access directly to this kind of data inside classes. And one more thing, let's say that you don't want to watch this warning. To remove it, you just have to do the next. Go to the declaration of that method. And let's say for this same method that every time you shoot, you're going to lower the ammo by 1. So just go to ammo minus minus. Look that here I am controlling the value of ammo inside the method. But I can also add other conditions, like for example, if ammo is less or equal than 0, return. Which means don't do a thing. But if not, I will continue the process and reduce the amount of ammo. This is a good example of why we don't allow the access to ammo directly, because it could be other conditions that you need to consider inside your entire program that the developers or the gamers don't know about. I invite you to do something similar, but with the reload. I want to use this same example to explain what are members and methods. Members are the variables, the data inside your object. In this case, for example, a member is ammo. Methods are the functions that operate on the data. As you can imagine, for this case will be shoot and reload. This structure is the backbone of every Unreal gameplay class and is key to dominate any language that uses object-oriented programming. The next concept we will cover is constructors. Constructors run automatically when an object is created. They prepare your object with initial values. Imagine that they set up the basic variables and the basic elements that you need to operate your object. Let's do an example. Create the class player. And inside the class player, let's define a public integer health. And now the constructor. Let's say that by default, I want that the health of any player starts in 100. In the declaration of the constructor, I have to use the same name of the class, exactly the same. So I will declare it as player. This will be, by the way, the default constructor. And I will assign to health the value of 100. So if at any point I decided to create a player, I know that that player will have a health of 100. It's the default constructor. Even better, you can have multiple types of constructors. Let's say I create another constructor. It has to have the same name of the class, but in this case, I'm going to pass a parameter, initial health. This will do the same thing, only that in this case, I am passing the parameter of how much health I'm going to give to initial health to this player. So now let's say that in integer main, I can clear a player that is called, let's call it default player, and another that will be player custom player, and I will pass the value of 250. Let's get the information from them. And let's run. Here you have the hello world at the beginning, and then default player 100 and custom player 250. Both of these variables are players, or are the type of class player, and they could have access to future methods that I add, but they were created with different constructors. Now that we covered the constructors, let's talk about the destructors. Destructors run when the object is destroyed. You use them to clean up memory or release resources, which means that they are very, very important. The destructor starts with a tilde, which is this weird character. And you just use the same name of the class. And then you just clean up anything that you need here. Even though this is necessary in C++, I would say that in Unreal, you rarely write destructors because the engine manages most of the memory. But it's essential to understand the concept. In normal C++ usage, you never call a destructor manually for an object created on the stack. The destructor is called automatically when the object goes out of scope. For example, let's say that you create an object inside the main, and well, once you finish running main, the object is destroyed. In this case, as soon as the, let's say, default player reaches the end of this scope, the destructor player is called automatically. Let me show you by adding a simple line of code. Let's say cout cleaned and standard end of line. Remember that we create first the default player and then the custom player, and then we finish the entire code inside main. As soon as we reach the end, then we should clean this memory. Let's check it. Here we have it. We create the object, we present the values, and then clean for each of the players that we did. Each of the players. There is another scenario where the object is created on the heap. We covered this on the previous lesson. But let's say I create a new player that is called player special, which is a new player. And we can also present its value. In this case, you have to remember that we have to call the delete player special, which will call at the same time the destructor. Let's test it. Now we have the creation of the first three and also the call of the destructor. But also look that if we comment this line and run, the last cleaned is not called. This is a memory leak. So remember to call the delete when the object is created on the heap, which means that you use the word new. Let me create another integer main and comment this section. The last thing I wish to cover today on this lesson is the this pointer. Inside a class, the keyword this refers to the current object. This is useful when parameters have the same name as members or when you want to return the object itself. Let's create a new example. Let's do the class item. Private, let's call an integer, which is a value, and then a public, a method called setValue, where we pass the parameter value. As you can see here, we have a parameter inside our class that is named value, but we're also passing a parameter using the method setValue. So how can I differentiate this value from this value? That's when we use this. In this case is this value, which as you can see it refers to the value as a parameter in the private section. Look at that it is the same box. And I would say the value of that parameter will be value as the parameter that is sent using the method setValue. I hope this clarifies how this works. It is a simple thing that will help you have more control inside your code and your classes. Now you understand the fundamentals of object-oriented programming in C++, structs versus classes, how to encapsulate data, how constructors and destructors work, and why this pointer matters. In the next lesson, we'll go deeper into object-oriented programming, exploring polymorphism, abstract classes, interfaces, and static and dynamic binding. Like, subscribe, comment, share, and ring the bell so you continue progressing as a C++ programmer, and also to access the creation of Mad Gameverse, my newest third-person shooter developed in Unreal step-by-step in this channel. And don't forget to visit Woolen.com to learn more about the Game Creator Accelerator Lifetime Mentorship Program and discover how to build a path into the gaming industry even after office hours. Set a chat one-on-one with me to figure out where you are, what you want to achieve, and how the GCA could help you. The link is in the description. Until next time, keep creating, keep sharing, and most importantly, keep dreaming big. I'll see you soon, my fellow creators.